Welcome to this presentation on the visual pathway. The first topic that I'm going to guide you through on this journey along the pathway is the passage of light through the various components of the eyeball. And this is necessary to focus the light on the fovea centralis, the point at which we have the greatest visual acuity. The first structure that light will pass through is that of the cornea, which you see labeled here. Next, the light will pass through the aqueous humor, and then through an aperture of the iris that we call the pupil, and you see that opening labeled here. The lens is the next structure through which light will pass along its travel. And then its greatest journey is going to be through the vitreous humor. And then the light will hit the retina, and by striking the retina, photoreceptor cells will become activated. This slide depicts the major layers of the retina that will allow the visual scenes to be delivered through the optic nerve. First, the pigment epithelium is shown here. This is the external-most component. The purpose of the pigment epithelium is to absorb any scattered light, which helps with visual acuity. The photoreceptors are shown here, and we have cones and rods in through here, and we'll speak to those in detail shortly. From here, photoreceptors will stimulate bipolar cells, and then the bipolar cells will communicate and activate ganglion cells, and then the axons from these ganglion cells will then form the optic nerve, and the optic nerve is forming right here on the right upper portion of this image. Now let's take a look in greater detail about the photoreceptors. First, we have the rods, and here's a nice illustration demonstrating a rod. And then the cones are shown here, or at least one cone, and you can see this cone-shaped appearance here to the outer segment of this photoreceptor. Now let's describe the functions of the cones and the rods. The cones are located specifically within the fovea centralis exclusively. There are no rods at this place. As you move outside of the fovea centralis, you're within the macula lutea. The cone density will start to decrease, and then rods will start to increase in density. And then once you get to the periphery of the macula lutea, then you have exclusively rods in the peripheral aspects of the retina. Cones are necessary to operate in bright light. They are responsible for conferring color vision, and in order to do so, there's a population of red, green, and blue cones. They are responsible for high visual acuity, and if we have an excessive loss of cones, this is a cause of legal blindness. Rods, which start to show up outside of the fovea centralis, and then we see them exclusively outside of the macula, are responsible for low light vision. As a result, they have poor visual acuity, and they are responsible for achromatic vision, so we see scales or shades of gray and not color. And excessive loss of rods impairs our ability to see in low light or during nighttime. Thus, this can be a cause of night blindness. The retina, in certain situations, can become detached. And when that happens, There's a separation of the neuroretina, which would be the boundary between the photoreceptors and the pigment epithelium. As a result of this separation, the neuroretina from the pigment epithelium, blood supply to the photoreceptor cells is disrupted. The blood supply to this area is from blood vessels that reside in the choroid, which would be down in this area here. And so you are dependent then on the diffusion of the components from the blood to maintain the viability of the retina. That becomes lost when we have detachment. Retinal detachment can cause a shower of pepper or floaters as visual sensations. And the shower of pepper or the floaters that are seen visually are extravasated red blood cells due to a disruption of the blood supply.